Okay, hello, this is Dr. Janes. Hello, this is Dr. Janes, and today we're going to talk about an interesting experiment. We're going to try to do tritium fusion in our basement. And the first thing you have to do is get a hold of one of these things, which is probably the most difficult thing to do. It's an exit sign. I've actually taken this thing apart. I don't know if you can see here, it's got some warnings. Let's take a look at this. Take a look at that. Anyway, it's radioactive tritium. Okay. And so, these are nuclear powered exit signs, so you don't have to worry about the electricity going out. They'll always light up. So let's, what I had to do is I had to take this guy apart, and it's got some glass in here. It has some kind of recesses. I kind of cut the thing apart. It's hard to get it apart, but there's like little insets, and there's let's take a look at these things. Inside these insets here, so here's an X, and here's an X here, and here's one of the tubes that would go inside of these insets, and it has radioactive tritium in there, and that tritium hits some kind of phosphorescer, and it causes the exit sign here. Get a good look at the exit sign to light up with these tubes inside of it. Let's take a look at this. Just so you can see for sure. Here. Okay, can you see that on the camera? The camera's not really picking it up too well. It is glowing, but it doesn't seem to be bright enough for the camera to really see very well. Let's take a look at this again. Let's take this out of here. This tritium is getting a little bit older too, so it has a half-life of like 12 years. So there's our tube, and it's got some kind of glue stuff on it. We turn out the lights. Now, this camera's not really able to see that very well. I can see it with my eye, but anyway, try it again. Yeah, the camera's not seeing it very well in the dark. Anyway, I can see that. So, it is glowing. It's not glowing too bright anymore. It's an old exit sign. And so, the idea is, what if we could somehow put electricity through this and heat up the plasma inside? Let's see, I just made, these are just wires, and I wound them around. Okay, so we have our tritium tube here, and I'd like to point out that tritium is a very good source of fusion energy. Okay, so we got our wires here. We can take these wires. You can't see it very well in the white background. So we can take our wires here and slide them over the end of the tube. And for those of you out there that study Maxwell's equations, you would know that, see, there's no way for me to put electrodes on this. This is a sealed tube. It's all glass. But you know, if you study Maxwell's equations, that you can generate an electric field by having a changing magnetic field. So we can actually generate an electric field inside of here, and maybe we can excite that plasma, and if we can get it hot enough, maybe we'll get some fusion neutrons coming out of it. Okay. So anyway, the big question in my mind was, can I excite this enough to start a plasma inside? Because even if you can't get up the fusion energy directly, you know, every plasma has a Gaussian distribution, and a certain amount of those particles are going to get up to possibly fusion energy, and so it's just a question of how much. But once you get that plasma ignited, there's a possibility there of doing fusion energy. And of course, the tritium decays to helium-3, which is also another good candidate for fusion energy. Both of these guys are great for fusion. And let's take our device and see if we can hook it up to high voltage, an AC high voltage field, an alternating current, and see if we can excite a plasma in there, and then maybe we can get some neutrons off of this thing. Okay, so here we go. So what we've done, I should get a flashlight down here. Too dark to see. Here we go. What we've done, got a little flashlight here. So I built this nifty little power supply using an Arduino to pulse modulate. Have some big ass capacitors here and some transformers and other things, and we have different dials that control the frequency of different modulations. I have pulse width modulation and frequencies, so I can tune it to these big ass. These are racing coils for race cars, and they put out 60,000 volts apiece, and so I can drive them out of phase to produce over 100,000 volts in principle. And I'm switching in with FETs here, and have some resistors to try to balance the power at low power as well, because I like to be able to turn the power up and down. And here we've connected our tritium tube here to the outputs of the transistors, and of course they're coupling. And people know Maxwell's equations: del dot B equals d dt, or del cross B equals d dt, and del cross E equals dH dt. So you can generate an electric field by having a changing magnetic field, and vice versa. So AC fields will couple capacitively through the tube and hopefully ignite it. And so let's see what happens here. Okay. So there we go, and turn the power on, and look at that. We're able to excite a plasma inside, and I have it pulse modulated. I'm having it turn it on and off, and of course it's modulated in the transformer too. So we are actually, turn off the lights. So we are exciting the tritium plasma. Of course, there's probably a lot of helium-3 in there also, with high voltage. So are we getting fusion? It's a possibility. Definitely, I'm sure that there's some fusion going on. It depends on, you know, how many atoms are reaching fusion energy, whether it's just the tail of the Gaussian or whether it's a large portion of them getting up to fusion energy. But I bet we're probably getting neutrons off of this thing. So we'll have to get out our neutron detector. Probably in the next video, if there's interest in this, we'll see if we can measure any neutrons coming off of this guy. Okay, let's see if we can turn up the power maybe. Tune it in a little bit. Of course. Okay, so I can change the pulse modulation duty cycle there. We should get a higher power out if we run it for a shorter pulse modulation time. Try to tune the frequency so it's tuned in better. Okay, change the pulse modulation. Okay, there we go. This is the duty cycle here of the main pulse modulation. There, we're starting to put more power into it. I think it's looking quite a bit brighter now. Tune the frequency in a little bit. Okay, anyway, so it looks like we're getting a we're definitely exciting a tritium plasma there. Anyway. View the whole apparatus. This is Dr. James. Thanks for watching.